So, first of all, NAFEN, I call it our evolutionary product. Why? Because you've already seen from the presentation over here the process that NAFEN has gone through in order to get where we are today. The material started off as just this discovered material. Then it became a material that could be used on an industrial level. Then it became a product that could be easily used in development of new products for all these new industries and high-tech industries. Then we got the recognition of NAFEN's value through feedback from our customers, as well as a grant from the Horizon 2020 program from the European Commission. These are all the steps that we've gone through to get to where we are today, where we actually need to grow out of this facility and build a new one. So as you've learned from the earlier presentation, NAFEN is pure alumina. This is aluminum oxide. As you saw from the demonstration, it's grown off the surface of molten aluminum. This is a very unique process. We're the only ones in the world who can produce this. Some of the properties of NAFEN, why it's unique, it has a very high aspect ratio. As I alluded to in the lunchroom, a lot of nanomaterials are spherical and they don't have the strength properties that NAFEN does. The size of the nanocrystal is around 300 nanometers as a mean average. It doesn't mean a lot to you maybe, but for the industrial world, having a high aspect ratio means there's a strong reinforcement property that they can utilize. Having a large surface area also makes it very useful for the development of these polymers and ceramics, because what happens is that large surface area gets to interact with those other products and you use less of the material. So the larger the surface area, the less material you have to use to make a difference. In comparison with carbon fiber, which everyone's heard of carbon fiber, NAFEN's strength properties are significantly higher. So this is one thing that attracted a lot of our industrial customers to NAFEN, is the fact that it is intrinsically stronger than the other materials that are already being used for reinforcement. When we say that NAFEN is pre-dispersed, you saw how it was taken out of the oven there. It's all grown in the same direction, which means that it's basically already dispersed. All we have to do is put it into a liquid system, grind it down to the smallest size we can get it, and it creates this benefit for the customer. So one of the other advantages is that because of this predispersibility, NAFEN is very easy to get into systems that other products like carbon nanotubes, nanosilica have problems getting into without what's called agglomeration. They can get it to separate, but then when they put it into a dispersion, it all sticks back together again. So they completely lose the whole nano effect. So anyway, as I said, we're here, pilot production, 10 tons a year. We need to step that up to at least 80, and that's why this new production facility will be such a value to us. So again, touching on this revolutionary product, it's changing the industries. It's helping to achieve these lightweighting objectives for aerospace, automotive, and other industries. One of the new evolutions of NAFEN is being able to put different surface treatments on the fibers, which changes the functionality. So NAFEN as itself is a crystal. So as it's produced, it does not conduct electricity. We now have the means to coat that with graphene. So it's basically a carbonized version of this material, and that becomes electrically conductive. So it completely changes the physical properties, but it still has the strength properties. So this is now something that we can go out and we can compete against carbon nanotubes, graphene, and these other electrically conductive materials, as well as offering the strength properties. So these are some of the areas that are actively using NAFEN right now: automotive, aerospace, wind energy. Some of the applications they're putting it into are high temperature stability composites. So what happens is when a composite gets hot, it begins to lose its strength and form. So NAFEN helps to reinforce the resin system to hold it together at higher temperatures. This also applies to adhesives and sealants, which are used in producing cars, airplanes. motorcycles, bicycles, and all these other things. So some other areas that are outside of the polymer field, NAFEN works effectively in cements. So NAFEN is hydrophilic, meaning it absorbs water. So when you put that into cement, it holds water longer during the hydration process, and that creates a stronger cement. So within the first 24 hours of curing in a cement, NAFEN increases the compression strength by 50%, and then holds that over the 28-day curing process to hold a higher compression level up to about 15% higher than standard. So we're looking at ultra-high performance cements and working with customers in Asia as well as America and Europe to try and develop a system of putting NAFEN in effectively and on an industrial level into their formulations for creating those high-performance cements. So with marine, we were introduced to a problem in the coating systems for corrosion-resistant paints. There is a hundreds of millions of euro problem that the coating companies are facing, where they get warranty claims from the ship companies where their paint is cracking and their ship holes or components on their ships are rusting because their coating, which is supposed to protect the metal, is cracking before the warranty is over. What they discovered is that they need a paint that can withstand the flexing forces of these new construction methods that are being used for vessel construction. The components are so large they can no longer build a ship all together at one time. They have to build components in one site, bring it to this place where they're putting everything together, and from there they have to crane everything into position. What that creates is a lot of flexing forces, and that paint that they're using right now can't stand those forces and it cracks. They don't always see those, so they build the ship goes out, and it starts rusting. Then the warranty has to be claimed, and the paint companies are paying millions. So they're willing to pay a premium for a product that will help to alleviate that. So these are the kind of things that we're looking for in terms of using NAFEN. All right, so as I said, these are some of the industries that we are actively working in: automotive, aerospace, marine, protective and ballistic armor materials, construction and civil engineering, renewable energy, oil and gas, and high-performance sports equipment and electronics. Now, NAFEN does different things in each of these, and in each of these it does something similar. So depending on what the customer is looking for, what their needs are, they're able to actually achieve something that solves the problem that they're facing. So for example, in electronics, they're looking for protection of the components for abrasion during the process. Let's say in electric motors, they need to protect the other components around it so they're not influenced by the electrical current. So they use NAFEN as a dielectric shield. So they load the epoxy up with that, and they cover the components with the epoxy, and that shields it against those influences. I've talked about some of the other applications, so we'll move on. So what are we doing with the ICO? We alluded to this briefly and several times during the presentation. We need to build a larger facility. We'll still be here in Estonia. The product was discovered here. We've built the company up around it. There's great legislation, good company tax systems, and obviously great talent available to us. So we're going to build a new facility, and we want that to produce 100 tons per year. To do that, we estimate we need $14 million, or euros. So we're launching the ICO to achieve that. So the basis of the currency, this is where it all gets interesting. You guys have been listening to all the information about different ICOs and things. The NAFEN ICO is going to be a little bit different because we're going to actually have a utility token which will be collateralized with NAFEN itself. This is different because as far as I understand from talking with different people at the conference, there is no other collateralized crypto token. What we mean by it being collateralized is that one token will be worth 1 gram of NAFEN. This will be a voucher for being able to exchange a token for a physical product. What that means is that the industrial companies, I think you might want to add the rest of the, what that means is that when a industrial customer wants to buy NAFEN from us, we will go to this crypto stock exchange where the NFN coin will be listed, and we will buy those tokens back in order to make sure that every gram of NAFEN that's sold will be exchanged for a token. So just a graphic image of how we see this, that the tokens will be issued. You guys will, or friends of yours, they'll purchase the tokens. We'll then be able to sell the tokens or exchange them for the NAFEN fibers going forward. So as I've said several times, the objectives of the ICO are to construct the larger scale production facility, to be able to optimize the production system that we have and be able to lower the overall cost of production for NAFEN fibers, which allows us to enter markets where larger scale and lower prices have been demanded by companies, and we haven't been able to approach them with this material because of that simple disparity in terms of what their cost needs are. And then one other idea that we have is to establish another pilot or foothold facility in the United States. As we have a lot of customers that are based in the US, we want to be able to make localized production for them going forward. So we would start with a similar facility like this to be able to start producing the nanofibers there and address that market on a more aggressive scale.